So let's come to discuss about this decentralized system. In last lecture, we discussed about the centralized system, where there is a one centralized unit in term of server, and we have multiple clients users. In decentralized, as the name shows, there is no centralized server, but rather every client have a dedicated server, and all the clients are independently working. These are other types of systems that have been gaining a lot of popularity nowadays, primarily because of the massive hype of bitcoins. So now many organizations are trying to find application of such systems. In decentralized systems, every node makes its own decision. This means every node, every computer is independent in computation. The final behavior of the system is the aggregate of the decision of the individual nodes. So there is a, if we talk about the distributed system, so we already stated in detail that for user that is a one system rather than individual systems, and there is a specific goal. So for a specific goal, we have to aggregate the decision of the individual nodes. Note that there is no single entity that receives and respond to the when we talk about the decentralized systems, we will mostly find the word peer-to-peer. So peer-to-peer is actually the peer-to-peer links, one-to-one links between two nodes. So nodes in the decentralized architecture, decentralized systems act as a both client and server. So already stated that there is as there is no centralized one server unit, so this means every system must have a dedicated server, and interaction is symmetric. So each node act as a server for a part of the total uh, system data. So we can also say that in peer-to-peer or decentralized system, one node, one computer act like a master, which initiate the activities, and rest are like the clients. But this does not show the asymmetric distribution. Overlay networks connect nodes in a P2P system. So what are the overlay networks? Overlay networks are actually the logical networks that are laid down above the physical network. So nodes in the overlay use their own addressing system for storing and retrieving data in the system. Nodes can route requests to location that may not be known by the request. So what are the overlay networks? It is the logical or virtual networks built on the top of physical network. A link between two nodes in the overlay may consist of several physical links. So if we have the overlay network between two nodes, so this means it can consist of many physical links. Messages in the overlay are sent to logical address, not a physical address. So if we talk about the overlay, we can take example of VPN, virtual private network, that are created for some specific organization. So and virtual IP addresses are assigned. Various approaches used to resolve logical addresses to the physical. So overlay network example is like this. We have peer-to-peer link. So these are the distributed nodes, independent nodes, which consist of, which act like a which act like the client as well as server, and there is a peer-to-peer, one-to-one directed uh, communication links between the two nodes in the overlay in the this decentralized architecture. So you can see this figure. There is no centralized architecture. There is no centralized server where all the clients are surrounding them, but rather every node is a independent. Overlay network. Each node in the P2P system knows how to contact several other nodes. The overlay network may be structured, or this means nodes and content are connected according to some design that's simplify later lookups, or unstructured means content is assigned to nodes without regard to the network topology. So this means in structure overlay network we follow some topology, specific topology, and it may be unstructured. So there is no specific followed structure, but it can be unstructured. So when there is another mixture category which is called hybrid architecture. So what hybrid architecture do? It actually combine both the client server means centralized and P2P means decentralized architecture. So edge server system is used. So edge server systems are the servers which are used to connect to different networks or to different architectures. ISPs which act as a server to their clients but cooperate with other edge servers to host. So let's come to take example of BitTorrent, which is a distributed system and work on the decentralized architecture style. So BitTorrent is a communicational protocol for peer-to-peer file sharing, which enable users to distribute data and electronic files over the internet in a decentralized manner. To send or receive file, user use BitTorrent client on their internet connected computer. So it is a quite a fast system, and files can be downloaded in a quick quick can be downloaded quickly. So using information from the tracker, clients can download the file in chunks from multiple sites in the network. So if we have a file size which is bigger, so it is divided into chunks, and so it is search for in different client in different nodes, peer nodes, and then it is downloaded in a chunks, multiple chunks, and then integrated from multiple sites in the network. Client must also provide file chunks to other user. So this is an example. We have multiple nodes connected. We have a client who is searching for some file. We have seeders and leechers and trackers. So let's come to discuss briefly about these terms here. So seeder is a peer that has an entire file. So any peer, any node, any user connected to peer node who is mm, who has a entire file is a seeder, and leecher is a peer that is downloading file. So anyone who is currently downloading file will be a leecher. So a leecher can download file from seeder. Leecher have some files, not a complete file. So as Leecher is downloading a file, so he has some file, but he has not a complete file. So once the Leecher download the complete file, it become a seeder. So this means the Leecher is converted to seeder once the file is downloaded. So this means he can laterally share it. So a BitTorrent tracker is a special type of server that assists in the communication between peer using a BitTorrent protocol. So we have a seed and we have a leech here. Leech is downloading the file, and seeder is a provider. So if we come to this slide, so tracker is a special type of server that assists in communication between PD using a BitTorrent protocol. So when the user requests for the file, so there is a tracker server. So this is a tracker server which is connected, and the purpose is to look for the particular file with different seeders. So this is the example you will better understand. So client node, and this is the client who is requesting. So who is requesting, so it like see Leacher. So he has a BitTorrent web page, and he give reference to the file. So he will provide the reference to the file dot torrent file for the file server. So he will um, mm, provide the address of the file that is on the file server. So it will call a tracker, and tracker will look the file in different nodes, and then in parallel distribution the file will be downloaded from different nodes in less amount of time. So tracker is just a simple HTTP server that hands out peer information to the network and periodically collects stats from different peers. So this is this is a client who is searching for the file. So he search the file, he get the information, uh, he put the file information, and there is tracker. So tracker keeps the information of the seeder which possess the seeder who possess the file, and all the stats of the peers are with the tracker. So and then Cedar provide that file to that particular client. So you actually, when you put a file information and that is put forward by the tracker, so this means indirectly you are calling some Cedar for the file. So that is actually the tracker responsibility to look for it, and then file is downloaded for you. So this is the best example with torrent where the multiple peer nodes are connected and collaboratively work for the some purpose. With torrent justification, just designed to force users of file sharing system to participate in sharing, simplify the process of publishing large files. For example, games. If you are looking for some games and you want to download it, so the game size is quite larger, so quite large. So it is looked in different peers. When a user download your file, he becomes in turn a server who can upload a file to other requester. So this means when user download file, when leacher download the file, he become the seeder. Bitcoin example, let's take Bitcoin for example, because it is the most popular use case of decentralized system. No single entity organization owns the Bitcoin network. The network is the sum of all the nodes who talk to each other for maintaining the amount of Bitcoin every account holder has. So Bitcoin is another example. Characteristics of decentralized systems: a lack of global physical clock. So every node is independent of each other and hence has a different clocks they run and follows. Every node has a physical clock. There is no one common clock, but rather there is some logical clock. Logical clock is created through some algorithms, and then the tasks are assembled and synchronized. Multiple central units, computer, node, server, more than one central unit which can listen for connection from other nodes. Dependent failure of components. One central node failure cause a part of system to fail, not the whole system. So this is the advantage. If we have 20 peers and one is down, so it will not affect the whole system. It scaling is vertical scaling is possible, but mostly the scaling is horizontal. So each node can add resources to itself to increase the performance, leading to increase in the performance of the entire system. Remember that vertical scaling purpose is to increase the performance. For example, if we have one system peer node and there is a dedicated server for that, so we can add more server to that. So to increase the we can add more server or hardware resources so that it is become more efficient. Components of decentralized are nodes, which can be computer, mobile, and communication peer-to-peer links. Architecture of decentralized system is peer-to-peer architecture mostly. All the nodes are peer of each other. No one node has supremacy over the other nodes. master slave architecture. One node can become the master by voting and help in coordinating of the part of system, but this does not mean the node has supremacy over the other node. And I already stated this point that one node become the master. It actually that node actually initiate the process, but this does not mean that that node will have supremacy and control over all the nodes. But it actually bring coordination among all the peers. Limitations: it may lead to problem of coordination at enterprise level. When every node is owner of its own behavior, it's difficult to achieve collective tasks. So collective task coordination become the difficulty. No, not suitable for smaller systems. So for smaller, we go to rather than going to decentralized system, we it is better to adopt the uh, mm, mm, centralized client server approach. No way to regulate a node on a system, no superior node overseeing the behavior of the subordinate nodes. Advantages include minimal problem of performance bottlenecks occurring. The entire system load gets balanced on all the nodes, leading to minimal to no bottlenecks situation. So load is balanced. High availability. Some nodes are always available online for the work, leading to high availability. As compared to the centralized, where the dependency of all the client users are on one centralized server. So if the server fails, so all the system gets down. But here availability is not a big issue. More autonomy and control over the sources. As each node controls its own behavior, it has better autonomy, leading to more control over the sources. Improved fault tolerance. Decentralized systems are designed to be fault tolerant, meaning that if one or more nodes fail, the system can still continue to function. This is because the workload is distributed across multiple nodes rather than relying on a single point of failure. Increase transparency. Decentralized systems often have a transparent and open structure which allows for greater accountability and trust. Each node has access to the same information, making it more difficult to manipulate or corrupt the data. Greater security. Decentralized system can be more secure than the centralized system because there is no single point of failure or vulnerability that can be exploited by a hacker. Data is distributed across multiple nodes, making it more difficult to hack or compromise. Improve scalability. So scalability was a problem with the centralized system. As the number of node increases, the scalability issue occur in centralized. But decentralized system can be more scalable than centralized because adding new nodes to the network can help distribute the workload and increase the capacity. This can be particularly useful for large complex systems that need to be able to handle high volume of traffic or data. Disadvantages: there are some disadvantages, associated disadvantages with decentralized system. It is difficult to know which node failed. So each node must be pinged for availability checking, and partitioning of work has to be done to actually find out which node failed by checking expected output with what the node generated. So as we have a chunk of peer nodes, so if some node failed, so the tracing of failure become difficult. Difficult to know which node responded. When a request is served by a decentralized system, the request is actually served by one of the node in the system, but it is actually difficult to find which node indeed served the request. Lack of scalability. So scalability can be the issue, uh, but as compared to centralized, scalability is less, very less, but it can be occur. Why? Because the decentralized system can face scalability issues as the number of node increases. This is because each node needs to maintain a copy for entire database, which can be difficult to manage as the database grows. Here in centralized, that scalability issue occur because of the number of client increases, but here when the node increases, so the load on tracker also increases. So this can be the problem. So this means there are some limits. So we cannot say infinite number of peers. Inefficient resource utilization. Decentralized system can suffer from inefficient resource utilization, as some nodes may have spare computing resources while other may have overloaded. So, as compared to centralized, decentralized possess this deficiency. Every node is independent and every node has a dedicated resources. So, um, although the load is balanced from as the client request come and the load is balanced, but resources are not same. Every computer has a different amount of resources. One has less as compared to other. So it may be possible that one's node have a shortage of resources and other have a spare amount of resources. This can lead to a waste of resources and decrease performance. So this means these are the disadvantage, but these are those issues which can be resolved. So if we um, uh, design operating system in a way which can look for that problem, so we can handle that. Lack of standardization. Decentralized system lack standardization, which make it difficult to integrate with the other system and can lead to interoperability issues. This can be a major challenge for organization. They need to work with a multiple decentralized system. In short, I would prefer this system for a big, when the number of clients are too huge and the number of or the system are too huge, so it will be better to apply this. But we should also handle all of these issues. We have, if we compare to centralize this system, for large system this system possesses more advantages, and maintenance is also not a big issue. Further application of decentralized system include cryptocurrency, not joined to become the part of system in which digital currency is exchanged without any trace and location of who sent to whom. However, in Bitcoin, we can see the public address and amount of Bitcoin transferred, but those public addresses are mutable and hence difficult to trace. Uses include blockchain. Blockchain use the decentralized cryptocurrency, and nowadays Google is also using and many social media network uses this application. So we have decentralized databases. Entire database split into parts and distributed to different nodes for storage and uses. For example, records with names starting from A to K in one node, L to N in second node, and O to Z in the third node. So architecture of distributed system is peer-to-peer. All nodes are peers of each other and work towards a common goal. Client server, some nodes become server nodes for the role of coordinator. Entire architecture, different parts of application are distributed in different nodes of the system, and these nodes work together to function application of the user client. So in distributed system, we can apply the mixture of both peer-to-peer and client server. So uh, different nodes will be there, and every node will have a dedicated resources server, and we can have one centralized server. So we can apply this for the complex systems. Limitations of distributed architecture include difficult to design and debug algorithm for the system, and no common clock causes difficulty in temporal ordering of events, difficult for a node to get global view of the system. Advantage is low latency than centralized. Distributed system have low latency, scalability, fault tolerance, increased reliability, cost effectiveness, improved performance are the advantages of distributed architecture. Synchronization issue is there, as there is lack of global clock, so synchronization issues occur, and that are handled by the complex algorithm. High development and maintenance cost is a issue, as we have a peer-to-peer links. So we have our LAN networks, we have separate peers with the dedicated resources. So definitely maintenance cost increases. Further application include cluster computing and grid computing. Uses mostly are SOA based system, multiplayer online games, organization using Google, Apple, and Facebook. So Facebook also use the distributed system. Google use, Apple use. So this was all about the decentralized system and distributed system applications. So thank you so much for watching my video. Thank you so much.